So we are going to start our talk about the browser exploitation framework and some new features we recently added that they will be pushed in the GitHub repository straight after the talk.
So basically this talk is all about social engineering with the browser exploitation framework, and we know that there's already some stuff in there, but what we did is based upon some work that we did at work. Basically, this is who we are. Michele is the lead core developer of Beef, and he also works at Trustwave, the same as myself, and I'm basically just a guy who has come along for the talk. So yeah, this is who we are. So the idea of this talk is that we want to give you like an introduction and basically talk to you about what we were asked to do at work and the problems that we kind of saw with this, and basically what we did to try and fix them. We're then going to talk about Beef, exactly what Beef is for those of you who have never seen a presentation by any of the Beef guys before or have never used Beef before as well. We're then going to look at the new extensions that Michele has written for the Beef framework, and then we're going to have a look at using these extensions along with the RESTful API to actually start doing some exploitation around what we're going to be speaking about today, these extensions.
By the way, who knows Beef already? Wow, first time.
So this basically comes from Wikipedia. It basically talks about social engineering. And I know there's a few of you out there, some of you have given talks about social engineering, and I don't know what you think about this, but essentially the way I see it is that you're trying to trick people into giving you some information. And this is exactly what we were asked to do with work. So we had a client who wanted to do some work with us, but basically said that our managers are not going to let us do this because it's going to cost too much money. So they said, if you can do some work for us for essentially free and show us how vulnerable we are, then maybe I can get some budget. So we kind of said, all right then, and myself and Michele got some time to do this. And they basically wanted us to find out how many usernames and passwords we could get, which I thought was pretty vague. So I just started like ringing up, doing the usual, asking questions as if I was an IT guy. Basically, I created a fake LinkedIn profile. I pretended to be an attractive woman, added loads of people.
He's not even an attractive man.
So we basically added loads of people, and everyone we added basically accepted us. We ended up getting 70 people from this company accepting us, including the person who asked us to do the work and also the CEO. And we were sending messages, and then one guy sent us a message saying, well, actually, who are you? I haven't seen you around the office. And we said, oh yeah, I'm joining in 2 weeks. I'm currently on gardening leave. And he basically came back and said, oh, that's cool. It's good that you come in 2 weeks' time because we've got a big data center change going on. This is where it's going to, and this is what's happening. And in the end, I got all of these names, and some, obviously on LinkedIn, people put their mobile phone numbers, work numbers, things like that, and the date of birth. So I ended up ringing someone, hey, I'm from IT, your date of birth is the 2nd of August, what's the year, basically trying to get some trust. He gave me loads of information, like where they log on to their emails, the fact that they use domain credentials to log on to their emails, loads of things.
And most importantly, we got the original email with the proper footer.
Yeah. That's right.
So like the enterprise email, so the template that everyone is using, HTML email.
So anyway, I then just went out and tried, can I have your password please? And he said no, so I basically gave up. And I kind of thought, like, what can we do? So we'd heard really good things about the social engineering toolkit. We'd heard that, the simple things of cloning a website and sending out an email, people are getting hits with it. And we thought, I doubt this will work, but Michele and myself thought, well, we might as well try it at least. So what we decided to do was clone the website, register a domain that was pretty simple. So imagine it was like mail.example.com. We just registered mailexample.com, and we then basically cloned it. Now, when we cloned it, we found a number of issues that were issues to us. I mean, some people out here might not find them issues, but for example, one of the issues we found is that when you clone a website, say you clone like .com/login, you can't mount it, or we couldn't find a way to mount it on our server as /login. It would only be mounted as the
root
domain
of your path in your domain, basically.
So we found that was an issue, and we also found like the mass emailer that was basically built into the social engineering toolkit wasn't very good. Like
that basically is this one. We are not joking. So social engineering. So basically, this is the social engineering toolkit code. And there are some mail templates, but as you can see, first of all, the mail is sent as plain text, so you cannot copy an HTML email with the proper footer and everything in order to have a proper looking good email. So you can only configure the subject, the body, and then you can attach a malicious PDF in order to do client-side exploitation. Fine, but we wanted something more, obviously. So
this is basically, we use Social Engineering Toolkit. Michele did some bug fixes, and with the help of a guy that we used to work with, he basically created his own mass emailer, which was pretty nice. It gave us the ability to put in HTML signatures, obviously spoof the domain name, things like pictures and stuff like that, and personalization as well. So putting things in like hello, using an array, putting things like hello, the first name of the person that we'd managed to get off LinkedIn, and it made it look really personal. So anyway, we did this, and we sent an email saying, we have an issue, you need to change your password, click this link, or log in. And within seconds, we got maybe like 6 or 7 different credentials, and we logged into one of them, and we were in there for about 2 minutes, and all of a sudden, the IT admin was like, do not click on that link. If you need to change your password, give me a call. So I thought, well, this might be a really good time to get more involved, and I pretended to be the IT admin and said, actually, please do click on this link, and here you can change the password. And it actually ended up being the same link as what I gave them before. So at this point, I get I get a phone call from our contact within the company. Let me give you a little bit of background story. We're actually doing an internal pen test for them at the same time. And the guy doing the internal pen test, all of a sudden everything drops. And he goes up to our contact and basically says, look, everything that I've just been testing has come offline. He says, yeah, the CEO has basically said from all of these emails that are coming through that we're turning everything off. So a lot of their internal presence and their external presence all just died, like in that split second. And he basically gave me a call and said, the CEO has asked me to turn everything off. I said, don't do that. He said, why? Is it you? And I said, I'm not telling you because it would break the surprise. But in the end, I'd made a few mistakes along the way. Like I'd registered the domain name with like my handle, which was TMAC UK at the time, and this guy actually ended up sending me one of the IT guys ended up sending me a tweet saying, "Get off our network." So it was really good, but obviously he got into a lot of trouble for that.
Yeah.
So yeah, we won again. We ended up sending this email out, and we ended up getting pretty much most of the credentials that we wanted from the emails that we sent.
After the second email, in fact.
After the second email. So this was really good. However, the issues that we found with the social engineering toolkit and the fact that we knew, because we were cloning the website and we essentially owned the website, that we could do things with that application that wasn't being done at the moment. So we thought, obviously Michele is the lead core developer of Beef. We were talking, and we kind of just both at the same time came up with an idea to basically say, well, what happens if we put the hook in? And we start, whilst we're getting credentials, start doing browser exploitation stuff as well. So this is where the idea came from, and this is essentially what we've been working on. But first, Michele's going to go through a little bit about Beef for those of you who don't know exactly what it is.
So, for all of those of you that knows already Beef, you can basically sleep now. But anyway, Beef is actually a nice tool that was created by Wade in 2005. And the original idea was to create a framework that allows you to create a asynchronous communication channel with only JavaScript, so with basically Ajax calls. This asynchronous communication channel is actually working in the following way. So, for example, let's say that you have a page where you can put some JavaScript. So it could be a phishing page, could be a persistent XSS, it could be a website where you found SQL injection and you put something malicious in the database that is then retrieved and rendered on a page. So whatever technique you want to use, there is a moment where your victim, or also like reflected XSS, you send a link with script source that is pointing to our hook function. So as soon as this JavaScript file that contains all the beef functions is retrieved, the beef init function is called, and basically the whole polling from the victim to the server is starting. This is working like this for basically two reasons. The first one is that actually as soon as we see the polling, we know that the victim is online and we can control it. The second one is actually that in the moment we want to send some commands back on the victim, usually the polling response from the victim perspective will always return 0 until we don't have in point 4 some commands to send. So the response of one of those polling requests will contain some content. In this case, beef execute, that is a wrapper. Inside there is basically the JavaScript code you want to send. This is actually retrieved from the response from the client and then added to a stack of functions that need to be called, and that at the end they are popped from the stack and they are called. And for example, we want to send a prompt dialog, and the prompt dialog was shown. So probably you didn't get the point, because I'm not good at explaining this stuff. So sudo only because I'm running on port 80. What the fuck? Yeah, this Mac is super slow from work. Without SSD, with PGP, painful. So we started beef. Okay, there is already a Nuket browser. I don't remember why. Anyway, so beef came with a nice web user interface.
Before we start, can we have a show of hands for anybody who works for EDF Energy? No, that's fine.
Yeah, because there are some cool stuff later.
Yeah, we're going to show you some stuff.
Let me remove this, because this was actually the demo. So let's start beef again. Sorry for that. So in one browser, we actually connect to the beef user interface, where you can actually see your hooked browser, so all the browsers that executed your JavaScript. In another browser, let's say that this is a page that is served directly by beef, but in a real attack scenario, as we will see later, this could be whatever phishing link you want, or reflected XSS, whatever you want. So right now, the victim is hooked in beef, as you can see here. And in fact, in our control panel, we can see the victim. As soon as the victim is hooked in the framework, a browser profiling is running. So basically from navigator plugins and other components of the exposed by the DOM and by the browser itself, we can enumerate basically all the plugins, depending on the for example, in Firefox, if the victim is Firefox, Firefox is very permissive, and you can enumerate the exact versions of every plugin. Different browsers act differently. So we can get everything, name, version, UA string. Also, for example, to identify exactly the browser, we are not monkeys. So basically, we are not relying only on the user agent because it can be spoofed. So basically, we enumerate some particular DOM object. So like window.opera is something that is exposed only by Opera. So we can actually create like a matrix and see, okay, this is coming as this user agent, but actually these are the properties. So for sure is probably someone that is modifying his user agent string. So the detection of the browser type and version is quite accurate. Then we have also, we already know exactly which techniques are enabled. So Java enabled, yes, so we can already play with our malicious Java applets, for example. And then cookies, everything else that is leaking from the browser. Now, beef comes with, well, some stuff like rider that basically allows you to say to the victim, do this request inside the domain that is hooked in BIF, because obviously you have the same origin policy restrictions. Then there is XSS rays, that is something that I added. You can read about that online. There is no time to cover everything. So just for a small demo, this is like all the commands that are currently in BIF and that you can launch through BIF. So right now Metasploit is 0 because we are integrated with Metasploit, and you can configure BIF to connect to Metasploit through XML RPC, and then you can launch every Metasploit client-side module through BIF. Except from that, I will show you, for example, the fake flash update, which is basically a social engineering module that displays a fake flash update, as the name suggests. But instead of installing effectively the fake flash update, is installing a Chrome extension that is actually contacting us back, and the Chrome extension has liberal privileges. So that malicious Chrome extension we will install through this method can actually access all the cookies, including HTTP only, can access all the tabs, so you can inject BIF in all the other tabs. So if the victim has LinkedIn open in another tab, and that domain is not already hooked in BIF, you can actually inject the BIF hook also in that tab.
I think the most important thing, though, is that it achieves persistence in a way that the other extensions and modules haven't been able to do, because obviously it's in your browser all the time.
So as soon as you close the tab, for example, or you navigate away,
it's still there.
Yeah, we have implemented some nice modules like man in the browser and overlay frames to try to achieve persistence, but always we are not always speaking about real persistence, except this malicious Chrome extension. So I do execute here. Now look at what the user will see in a second. Yeah. So this is actually completely done in CSS, JavaScript. So install, yeah, continue. This is something that you always get anyway. This is the moment where the user is saying allow or deny to install the extension, and a lot of users, they don't even know what it means, your tabs and browsing activity. Add. Here we can see a new hooked browser. And this is it. So basically, this is the extension itself that is hooked in BIF. And the extension, is basically running on a different sandbox. So what we can do, we can launch specific modules that are aimed to target the extension itself. And for example, we can have this get all cookies that will retrieve every cookie stored in your browser, including HTTP only cookie, because this was implemented in this way from the Chrome API. I'm not sure why, but. And for example, here now I usually clear all my cookies, but you can see, for example,
that he hasn't.
Yeah, that for example, this is HTTP only true, a Google.co UK cookie, but we still retrieve everything. So in case, for example, you are one of those nice users that always say, remember me in an application, the cookie life is always like, for example, 1 month. With this technique, you achieve persistence, so every time you close the browser and you reopen it, even without being in another phishing page, you are still online, right? And also, you basically can steal every cookie, including HTTP only, so it's a great thing. There are also a lot of other modules. For example, at the end of October, I will speak in RuxCon, releasing a new attack technique that involves sending custom shellcode through cross-domain post requests, and this will be basically a new component of BIF called BIF bind. And here you can see basically a lot of exploits that you can launch, from cross-site request forgeries on routers to stuff on some camera models, to other exploits that basically are sent cross-domain, for example, the famous JBoss JMX deploy exploit, and that basically we ported in BIF in order to be launched by the victim browser and get anyway bind or reverse shells completely from the victim browser. Yeah, so anyway, you can then obviously in the network area we have like JavaScript port scanners, DNS enumeration, and other stuff. And well, this is basically what beef is. So you should really try it. Anyway, the social engineering extension, as we said before, we needed something that could automate regarding sending emails. So a mass mailer that was easy to configure in order to having an HTML email. I have to say, like, okay, I have this HTML email, then I want to copy it in a template, I want to modify a few things in like 10 minutes, and then I want to send this phishing email to 50 victims, without every time writing scripts or modifying set or things like that. And obviously, I start coding it. So let's see the code directly because it's easier. So, yeah. So basically, this is the social engineering extension where we have a configuration file where you can basically specify which SMTP server to use, in this case Gmail, but obviously the idea is that you register a phishing domain in a VPS, you have root access, so you configure also postfix or another SMTP server in order that actually your phishing domain, that for example would be Gmail with double L, will actually be used both for your phishing content on the web and also from like AMAX records for the SMTP server, pointing to the SMTP server. Then the nice thing about this is actually that you can create templates. So for example, we have a default template. The templates are always the same. You create a directory inside here. You have two files, mail plain, that is actually your name, your mail in plain text, in case basically the HTML rendering is not enabled in their client. And we can specify placeholders. So name will be populated with the name of your victim. Link will be the link that you want to put there. And the HTML email is basically the same, but rendered in a HTML, same placeholders. Then the nice thing is, in case you want to clone an HTML email from one of your victims, a lot of times images that are added in the email are actually pointing to external resources. And a lot of clients, by default, almost every mail client by default is not loading those images, because originally you could execute even XSS and things like that, or leaking information anyway. So my idea was that you got an email, you download all the images and you put them here, for example. And then basically you specify in the template configuration which images you have, that will be here. And then you specify the content IDs. So obviously when you send an email, you can send content in line, for example. So the idea is to base64 the image, assign a content ID, and in this way, the result is that even the more complex email, for example, the one that I cloned from ADF Energy, that had like, as you can see, like 12 or 10 images. I downloaded the images, and then I modified basically the original email, well formatted, with the content IDs of the various images. In this way, Beef, when will create your email, will actually look at this array of images and will say, okay, I will base64 this, and then when creating the email, this email will be added here in content ID 1. And everything is sent in with like in line. So, yeah. So this is the first thing. And actually I think I was covering, the mass mailer first. Anyway, let's do it in this way. So yeah, this is the thing.
So essentially, everything that we had an issue with in set with the fact that there was no like footers available, or it was all in plain text instead of in just like HTML signatures, we were able to sort this out and implement it within the Beef framework.
Yep. And this is, for example, the email that is arriving in your mail client. In this case, I use Postbox in Mac OS X. This is the default template that is in Opus, obviously. So you can see that the Beef logo was an inline image, so I didn't have to click now you cannot see it, but later I will show you a demo so you can see that having the images in line, it's perfect because you get them rendered every time. Then obviously you can specify which kind of attachments you want in order to launch client-side exploits, having like a malicious payload in a PDF or something like that. So another nice thing about Beef is that we have a RESTful API. So basically to contact, in this case, the mass mailer, you can use, for example, curl, specifying the content type of your request, and then in the body, you specify the template that you want to use, the subject, the from name, that is very important because almost every mail client will display the from name and not the from address by default, unless you don't open the email with like in raw format. And then the link and the link text. So the link is actually the effective link that when the victim will click on your link email, the victim will go there. And the link text is actually the content inside the A tag, like href is the link, and then what the victim sees is the other one. And then the recipients is just an array of mails and name, and this will be used to populate that placeholder that we've seen before, like underscore underscore name. Yeah, so first of all...
yeah, go back.
Yeah, I need to go back, fuck. Yeah, so let's see.
It's important to note as well that with the RESTful API, if you haven't used it before, obviously we've been using curl, but you can use any scripting language.
Yeah. So as I was messing up the order of the slides anyway, I will show you three demos anyway. So now, this is one of the features of the extension. The other feature is the web cloner. That is similar to what set is already doing. So basically, you can specify the URL to clone, like in this way. You specify a URL, you specify a mount point, so where you want to be the phishing page mounted. And then the difference, for example, between this and set is that if you want to clone, as Tom said before, config login verify 2 in Yahoo, actually in set you could mount only basically loginyahoo.com/, and that's all. You couldn't specify the path in the mount point at the end. And
let me reiterate, not without messing about a little bit. We managed to do it, but we had to change some code.
Yeah, so anyway, doesn't make sense. And another difference is that actually you have a clone page, and that's fine. Then basically the page is modified in order to intercept the post request if, for example, you are cloning a login page. And then the beef hook is added as well. Then a new thing is that, for example, if you are cloning a login page, you intercept the post and you got the credentials in beef. Then in the same time the victim is hooked in beef, so you can already play with other modules. And then after, for example, the victim click on post, so you sniff the credentials, then if the original page can be framed, the original page is loaded in an overlay frame. Otherwise, you are redirected to the original website. Achieving, I developed it in this way because actually what we want is, again, persistence. So given the fact that like 80% of the sites are not using X-frame options, or if they use it, they don't use like same origin or deny. In this way, you can really have the victim hooked even after sniffing the credentials, so you can still play with it. And basically, let's see the demo. So, so the first one is the web cloner. So we start beef. And then I already copied basically the RESTful API call that will be documented as well as soon as I commit the code. So that is basically the command that you need to call in order to clone a specific page. In this case, we are cloning the login page of ADF Energy.
Which is why we're in the host file. In the host file, we're obviously just putting our domain name that we've essentially bought, EFD Energy.
Yeah, EFD, this
just
is
for demo
what you
purposes.
usually do in these cases. Just for the sake of the demo, obviously I didn't bought anything. Obviously I wouldn't present that in a conference.
You need to use the token as well to be able to use the RESTful API.
Yeah, you need to be authenticated. So basically we just clone the page, and it has been mounted, as you can see here, to this URL on your phishing domain. As you can see, this is AFD Energy, and the page looks exactly the same. And also this basically is sending a post request. So this has been modified in order that, so basically the action attribute of the form tag has been modified in order to point to this resource instead of pointing to relative or absolute URLs from the original website. In this way you can obviously get the post request to BIF and not to the original website. You log in, you got the credentials here, and then basically, as you can see, it was almost not identifiable. That now this is the real site, still on the phishing domain, but this is actually an overlay iframe. So as you can see, as I will show you in a moment.
It says obviously it's still in the URL as the phishing domain, but that's because of the overlay iframe.
Yeah. So the idea is that, for example, if you was using set, that is a great tool. I'm not blaming it. Anyway, you are redirected automatically after the post is intercepted. You are redirected to the original website. But thanks to the fact that this website was frameable, we were able to load the original website in an overlay frame. And now, for example, we are just demonstrating that the victim is still hooked in BIF, even if she navigates inside the iframe. Now she will get the prompt displayed. So until she doesn't close the tab or she doesn't type something different in the URL, until she browses the website inside the iframe, and she will probably do that, we are free to launch client-side exploits or other social engineering tricks.
I mean, even when the page can't be framed, there's still ways in which you can achieve some kind of persistence. For example, one of the other availabilities within BIF is that it'll just open up a new tab instead of just changing on that same page.
Yeah.
So if it's open in the browser in one tab, you're still hooked. So you still have the ability to achieve some kind of persistence.
Like the Google phishing is working in a similar way to that one. So basically, if the victim is hooked in BIF in one of the tabs and the other tab has Gmail open, you can actually send. Basically, there is like a cross-site request forgery in the logout button. So you can say to the victim, log out from Gmail. She will be logged out. A new tab will be spawned here. That is actually the phishing page of Gmail that looks exactly the same. And while she actually try to authenticate on that page, and you can sniff the credentials even there. And the other video instead is this one. So this is instead the mass mailer. So we are basically proceeding from the situation of before, when we already had the web cloning page up and running for the my account adfenergy.com. And basically, obviously, don't do that. I'm not saying that you should clone and do phishing attacks using ADF Energy. It's just because I'm a customer, so I received this email.
So it's okay.
So in this case, we are actually contacting again BIF with a RESTful API. As you can see in the logs, we are sending 2 emails from this email address using the template ADF Energy with the name ADF Energy, and you get all the informations. And in a few seconds, all the emails will be sent.
So you now know who to send your spam emails to.
Yeah. And now in a second, I will show you that we got a new phishing email. And this is exactly the same because the content is copied from the original email from them. As you can see here, this is pointing to AFD Energy. That is actually our page that was cloned before. And so the idea is that now the victim is hooked in BIF. You can sniff the post, so you can sniff credentials if she is gonna believe in that phishing email. And then she's loaded again in the iframe, so you can still play with it. Yeah. So the idea basically is that in your social engineering tests, now you can really, as soon as you get the HTML email from your target, you can just create a new template in BIF in a second. It really took me like 10 minutes to copy the original HTML email from ADF Energy, put it here, download the images manually, and then basically updating the source tags of these images in order to have everything in line. And yeah.
So going back to the inline thing, he said he was going to talk about it again, but as you saw when he loaded the email, there was no need to press like, you know, view these images or the.
I think I still got it here. Let me see.
It's basically, you have issues with that sometimes, so putting them in line that's.
Yeah, that's basically the way forward. Let's see. Yeah, some crap. Okay. No, this one. Dove cazzo esce original? Yeah, there was a way to show the original mail in this client, but I don't like the raw. Anyway, I showed the code is faster. So in the mass mailer here, email headers, email. Yeah, so basically this is actually the raw headers that are sent in the email. Content is positioned in line. And this is like the, let's say, magic that is actually like an RFC thing, so no magic here. So, yeah. What do we got? So still 20 minutes. And then obviously imagining combining everything in a real pen test where you are allowed to also launch client-side attacks. You clone your pages, you send your phishing emails, and then the idea is that you want to automate some client-side pawnage, right? So as BIF is integrated with Metasploit, what we can do is actually write a RESTful API script that is actually checking. For example, you can write it event-based or thread-based. So basically, you can have a script that is polling BIF through the RESTful API in order to retrieve all the hooked browsers that are currently online. Then enumerate, again from the RESTful API, enumerate which browsers, for example, are Internet Explorer 6 or 7, or which browsers are running a vulnerable Java plugin, because every information is already given to you by BIF. And then from that moment, you can say, okay, launch this Metasploit module with all the meterpreter post-exploitation thing you want. So basically you automate everything from the cloning of the page to the sending of the mails to the shells retrieval. And for example, if you think about, I think there was something from Tor, but everyone knows that you can modify the traffic in a Tor exit node. So there was a talk in Black Hat, in the last Black Hat, from a few colleagues of us. One was also Ryan Lin that developed the Metasploit integration in BIF. And they were speaking about injecting the BIF hook, altering HTTP traffic. So you can alter what is going out from a Tor exit node, and then you can obviously hook everything. At the end, the only bottleneck will be actually BIF, I think, because it's not, right now is not ready to scale for like, I don't know, thousands of hooked browser. Even if I heard that, for example, the Jester and other people that are behind the US government, they are using BIF for malicious purposes, but this is a tool for pen testers, so remember that. If you want to use it for something else, it's up to you. So the last demo is actually the one that is combining everything. So in this case, this was like the first video I created, so I'm using the default template from BIF, but just for demo purposes. Right now we are starting Metasploit. Yeah, I had to cut it, but no time, sorry. So we start Metasploit, and basically we start Metasploit with a specific RSC script that is saying load the message RPC service on this host in a way that actually that functionality is exposed and Beef can connect to Metasploit to launch modules and things like that. Metasploit modules loaded. Now again, we are doing a demo, so in a real phishing scenario, your target was tarsnap.com. That is a great website that is something like Dropbox, but with security in mind. And I use it, so I'm just saying that it's cool. So tarsnap, so with double A, is actually your phishing domain, right? The victim is in Windows, and she has as well in the drivers. I never know why the file is called like etc hosts, but anyway. So basically both us and the victim are pointing to the same phisher domain. So we want to clone again the login page of this tarsnap service. Use tarsnap and don't use Dropbox, by the way, really. And now this has been cloned. So the next step is actually using that link, including it in our phishing emails. So now we are going to send X emails to our victims with that link. Again, for demo purposes, I'm using the default template because the one from EDF Energy was not ready yet. And anyway, the mails are sent. The victim is authenticated in his client, in his mail client. In this case, you can see me and not like your from name because I'm using my Gmail account as the sender, just again for demo purposes. But ideally, if your victim has an SMP server that is not configured properly and that is acting like an open relay or is not requiring authentication if the domain of the mail of the from email is one of the recognized one in that domain, as we did in our previous test in Trustwave, you can actually have the from completely spoofed, from not only from a name perspective but also from a mail perspective. So this is the phishing link on the phishing domain. Yeah, again, it's logging here. Let me skip a bit this part. So we are sniffing again the post is sent to Beef so we can get the credentials and the data. Now, this site as well didn't have X-frame options. So, for example, if you use BARP, Pro, you can actually, even BARP is saying for you, this can be vulnerable to clickjacking. So, yeah, okay. So, still hooked, and we can still play. So, why? So, let's say that the victim now is logged in this iframe, and she's staying a bit there. Then she opens other tabs, but the tab is open. So, she's still hooked in Beef. So what we can do now, let's say that in the first case she was opening the link with Firefox. But for example in banks and other big enterprises there are still a lot of people that are using Internet Explorer 6, 7 or anyway vulnerable browsers. They only basically, yeah. So let's say that the victim opened originally the phishing link, so she's hooked with Internet Explorer 6. In fact, doesn't matter because you can exploit browser plugins. For the demo, for this demo, that version of Java was not actually vulnerable. So what I'm doing now, I wrote before a script that is using the RESTful API of Beef in order to do the following. So is authenticating in Beef, getting the hooks, getting the modules available, and then basically calling this method. So upon hooks with
Aurora.
Yeah.
Right.
So basically, if vulnerable, so if the browser name and the browser version match what we want, so like Internet Explorer 6 or 7, we are going to call we are going to send the Aurora exploit with all the configuration you want. So like the payload you want, in this case was reverse TCP interpreter, then the exit func and whatever you need. And in order to basically automate this, because if you think about it, if you have 10 or like 100 hooked browsers and you don't want to use the user interface to click every browser and pawn them manually or send your stuff manually. So you can create a script with a RESTful API that does everything for you, does all the checks you want for you, and then automate also the last pawnage phase. And this is basically what is happening. So I'm just calling the Ruby script I wrote. That is this one again. Yeah.
You'd already gone through this.
Yeah, I know. Anyway. Yeah, let's call it. So it's keeping Firefox 14, for example, because it's not matching the thing that we want. You see, you seen here that actually if you see here, yeah, this is the moment where actually the malicious code is sent, has been sent instruction, and then basically if you open the other tab, you got the interpreter shell. Sessions menu, you interact with the session, and basically to demonstrate that everything is working properly, you open, for example, what we love, so the calc.exe. Yeah. And yeah, so basically this is another example of how you can use BIF to automatically pawn all your clients. The difference, for example, using the auto pawn in Metasploit, because you can say, okay, I can use the auto pawn, but the detection and the matching of the modules is not exactly what I'm expecting. So a lot of times, first of all, auto pawn is not, I think, for client sides is not even more supported. I'm not sure about that, officially supported by them. And by the way, the idea is that in BIF you have obviously much better profiling of the browser. So before launching your client-side exploit, you can be sure that that browser is exactly the one that you want to target on that specific version and type or operating system. Or for example, as we are running this JavaScript, we can also detect a lot of times injecting, for example, an unsigned Java applet, even if it's not, let's say that the machine is not vulnerable to Java exploits. Anyway, you can inject an unsigned Java applet that doesn't need permissions to run, and the Java applet is retrieving from you, we have a module for that, is retrieving from you the exact architecture of the machine, because with Java you can do that. So you can basically also target exploits that, for example, are running on 64 bits only, on Spark processors and things like that. Customizing the shellcode in a way that the exploit delivery will be super accurate. And basically this is all. So if you have any questions, we have like 10 minutes.
Any questions? Green, the guy in the, yeah, you first.
Sorry, I must have missed something, but I didn't quite understand from where you're sending the email. You're sending it from private links from a different browser, from a different
No, you are basically sending the email from one of your SMTP server.
Or the victim's SMTP server if authentication isn't necessary. So basically what we, going right back to the beginning, I don't know if you were at the beginning, but right back at the beginning we were talking about mass emailers and how a lot of mass emailers, well, the social engineering toolkit one, didn't allow for to have, what's it called, signatures at the bottom, HTML signatures. And basically what we did is created a mass emailer that sits within Beef that allows us to send however many emails to however many different email addresses using custom, well, whatever SMTP server we want to, whether it be an open relay or a server that we own or something like that, to allow us to spoof a domain or just, you send emails from an SMTP server.
So you're sending the email from the Beef server to the SMTP, or you're doing it in the browser? That's
No, when you send an email, you always use an SMTP server, obviously. So basically, if you have your VPS virtual, if you have your machine online that is running your phishing domain, the idea is that actually in that machine you will have also an SMTP server, in a way that both the links that you create and the mail that you create are coming from the same phishing domain that looks almost the same. Ideally, this is up to you at the end, to the one that you want to target. So as I showed before, I was targeting ADF energy, and I registered AFD energy. So that is the idea, basically. Yeah.
Yeah.
I noticed that you've got the big control panel on the same domain as your sort of phishing domain.
You can actually restrict. Yeah, I know what you mean. You know, you can restrict the access from like localhost. Then you can VPN to the machine. It's not.
You've got like a target page for the phishing login. What would happen if the user removed the path part of it and just went straight to the target, just the target domain on its own, as in if they just removed?
Yeah, so this is something that we talked about
Basically,
previously.
what you can do is actually clone the same page and mount it on different, like you can clone the same page and say mount this on the original path, mount this on / before, and you can also mount it as many times you want, because every time you mount something, if something is already mounted, is actually overwritten. So you can say, to cover this kind of scenario, that this is a good question, you can do 2 web cloning calls with RESTful API, one for the original path and one for the root.
And also we were talking about this previously, and about how we could maybe clone more than just that particular page and maybe crawl backwards as well.
Yeah.
But obviously, like the actually doing that is, cloning one page is okay. I guess cloning a couple of pages is fine, but if you're cloning a whole website, then it becomes a little restrictive. It's something that we talked about, but is...
Yeah, because the idea is that basically it takes obviously a bit of time to implement something like this, but you can, for example, you say clone this domain, you can have a crawler that is crawling for you the website, then is retrieving every content for you, and then is mounting every content in BIF. So, for example, I don't know, in a few years when everyone will use X-frame options and that redirecting will not be possible, maybe it's an idea. And you have the footer with the BIF hook in every page, and everything is served by your server. I mean, it's up to you.
Would it be possible then for any path that you aren't currently cloning would just be put through as like transparent proxy, such that it's not actually running through, but it's still serving it so the user has confidence that they're actually on that particular site as well?
It is possible. It is possible, technically speaking, because behind the BIF, this stuff is managed with Sinatra and Rack. The point is that then you need to see exactly like how relative links are handled, for example.
Yeah.
That's
The issue is if they just take out the path in the URL, then they're just going to go, they're going to realize maybe, and if we redirect them back to the website or somehow serve it through some kind of iframe, then I don't know, it all depends on whether they're using X-frame options, I guess. You was next.
Have you come across any filtering of like Hook.js or actually looking at the JavaScript?
Yes, and that's why I developed the evasion obfuscation extension.
So, yeah, so there's basically, I think like last month you developed obfuscation
actually,
that allowed him to do a number of different levels of obfuscation on the JavaScript. I guess he's going to show.
Yeah, so basically there were a lot of system administrators that were confident that they were able to block this stuff with a regex on Hook.js or even on the server response headers, because originally there was written BIF, right? So basically there are two things that can help you evading these things. One is the web server imitation, that if you enable this, so you can basically emulate Apache or IIS, so the root page will look like an unconfigured web server, so Apache or IIS. Then the default 404 responses are like those, and that's it basically. And
I implemented that.
yeah, you implemented that. And then basically instead, regarding obfuscation of the hook itself and also all the modules that are sent, there is an evasion obfuscation that is disabled by default, is still experimental. And basically you can define here your techniques.
Yeah, you can use a chain of techniques.
And then you can chain them as you want. So for example, you can have the scramble that is actually scrambling the variables, for example, of like beef of every cookie with random names. And then you have, for example, the base64 that is base64ing everything, and then with like a bootstrapper that is obfuscated as well, you can actually get the base64 decoded. And then recently a French guy that is actually collaborating with us implemented the white space obfuscation that was presented in DEFCON 17. That is actually like encoding, if a lot of you for sure knows that is basically encoding, obfuscating the code using tabs and spaces, and then having a bootstrapper that is actually reconstructing everything in that way. Yeah, there are so basically, yeah, you can write, for example, your obfuscation extension technique here, and then enable the evasion, and then you can see here that you can specify your chain. And in that way, obviously, a regex only will not be enough. But even if they have something else like a spider monkey engine that is actually downloading our hook and then analyzing what it's doing inside, I mean, at the end, if you scramble the variables, and then obviously we can also implement something that will scramble the method names, the function calls, and everything like that. It's like a cat and mouse, you know.
Yeah. The thing is that, because we had the discussion about this previously as well with somebody else, and they were talking about taking the code and running it within some kind of sandbox and then seeing if it's an issue. The issue is that beef really isn't malicious until you start using the control panel to do things with. So if you're going to do kind of, if we talk about like on the fly kind of things, then actually you're going to find it difficult to find anything.
Because if you think about it, beef can be seen like Google Analytics.
Yeah, exactly.
Basically, because it's something that you add, and then that is something that is communicating back sometimes. And then another thing that you can do to minimize the likelihood that someone is actually preventing beef on some kind of content filtering solution, you can also enable WebSockets. So basically, also secure WebSockets. So basically, as soon as the hook is running in the victim browser, there is a check to see if WebSockets are supported, and if WebSockets are supported, there is a change of protocol, and from that moment you don't see anymore all the pull requests with like cross-domain HTML. You see only the streaming protocol, and by default I don't think even Firebug has the ability to analyze that at the moment.
Any more questions? No? Cool, thank you.
Thank you.